Hello my dear friends. Sorry, I have to adjust my mic. Okay, I have to adjust my mic. Okay. So in the last class we discussed about some important concept, that is RMS value, right? RMS value. So I already mentioned that what is meant by RMS value, or the essence of the RMS value, right? So the RMS value means it is the DC, or it is the effective value or DC value, or it is the effective value or DC value required to produce the same heating effect as that of AC circuit can do in a same circuit for same interval of time. That means if you connected an AC circuit, AC supply to a circuit for a certain time period, say it is 5 seconds, it produces a joule, it will produce a heat of 50 joule, and for the same circuit, for the same time period, for same heat, how much will be my DC value, or how much will be my DC voltage? That voltage is called as the RMS voltage, right? So now we have to see RMS voltage, actually it is higher than or lesser than the the AC value. Okay, that means the DC effective voltage is the RMS voltage, right? So that RMS voltage is actually greater than or less than the AC. That we have to see. Okay, so consider so let's give a heading: RMS value of AC. RMS value of AC. See, so this is my AC, right? Standard AC, right? So omega t axis, and let be V of t, and let be Vm, right? Let be Vm, and this is 0, this is pi, and this is 2 pi. So according to the definition of RMS value, there is an equation for finding an RMS value, finding the RMS value of a waveform. That is, Vrms is nothing but root of 1 by 2 pi integral 0 to 2 pi V of t square t omega t for omega t axis, and same Vrms will be equal to root of 1 by 2 pi, it is 1 by t integral t 0 to t V of t the whole square dt, V of t the whole square dt for t axis, time axis. That means if you are given a waveform and its x-axis is in terms of simply t, then you have to apply Vrms equal to 1 by t integral 0 to t V of t the whole square dt. Or if you given in terms of what, pi or 2 pi or 3 pi, 3 pi by 2, 4 pi by 2, like that, no? In omega t axis, if you are given the x-axis in terms of omega t, you have to use this equation. You have to use 1 by 2 pi integral 0 to 2 pi V of t the whole square d omega t dt, d omega t. So that is the equation for finding the RMS value. Okay, so let's examine what will be the RMS value of an alternating voltage. So we have the instantaneous value of the voltage, that is the AC voltage, is given by V of t is equal to Vm sine of omega t, right? Vm sine omega t, that is the instantaneous value of voltage. At any instant of time, you have a sine wave like this, no? Alternating current or alternating voltage is a sine wave. That means it's produced like a sine wave, right? So that will be represented by V of t is equal to Vm sine omega t, where Vm is the maximum value of voltage, omega is the angular velocity, and t is the time, instant time, right? This small t is nothing but the instant at which we are measuring the value. or V observing, that is the time period T. It is not the time period. Time period is nothing but capital T, right? I already mentioned in the last class, this is the time period, right? This is time period, not this. This is the instantaneous time. And according to the definition, Vrms will be equal to, see, it's a omega t axis now. So you can do for root of 1 by 2 pi, what is that? Integral 0 to 2 pi, right? Integral 0 to 2 pi V of t square d omega t, right? V of t square d omega t. Or in other words, I can write like, which is equal to 1 by 2 pi integral 0 to 2 pi. What is V of t now? It is nothing but Vm sin of omega t d omega t, the whole square d omega t, right? So Vm sin omega t the whole square d omega t. Or in other words, it will be 1 by 2 pi integral 0 to 2 pi Vm square sin square omega t d omega t. Is it correct? Sin square omega t d omega t. Okay. That means you can write like this, Vrms equal to, here this is Vm square is constant now, so you can take it outside from integration, that is Vm square divided by 2 pi, right? Vm square divided by 2 pi integral 0 to 2 pi sin square omega t d omega t, right? Is it correct? Is it correct? Which is nothing but, which is equal to integral Vm square divided by 2 pi. So no change in that. It is 0 to 2 pi as such. And what is the sin square omega t? Sin square omega t. Because the square integration is very difficult, so you have to convert that into simplified form, right? So sin square omega t is nothing but 1 minus cos 2 omega t whole divided by 2. Is it right? That is nothing but you have a relation like, see, sin square theta is nothing but 1 minus cos 2 theta whole divided by 2. So this is our equation. This is our equation. So that is applied here. That is applied here. So you have, it is d omega t. It is d omega t. So now 2 also constant, right? So it can also be taken outside. So it will become root of Vm square divided by 4 pi, right? Vm square divided by 4 pi integral 0 to 2 pi 1 minus cos 2 omega t and d omega t. So this is the integration factor. Okay. So it is nothing but, which is equal to Vm square divided by 4 pi as like, and what is the integration of 1? What is the integration of 1 with respect to d omega t? We are integrating now. So the answer will be omega t minus, what is the integration of cos 2 omega t? It is nothing but sin of 2 omega t by 2, right? By 2. Whole by 2 nahi, it is simply by 2, right? So integration from 0 to 2 pi. The limit is from 0 to 2 pi. So this is basic integration now. I am not going to how it is obtained and how, what is the integration rule and all. I hope you already know this now. Integral cos 2 omega t is nothing but sin omega t divided by, what is that? 2 omega, right? Divided by 2 omega. No, it is simply 2, right? Because we are respective with omega t, right? So it is correct. So sin 2 omega t divided by, again, d by dt of d omega t, that you have to take it as a denominator. So divided by 2, correct. So it will become, see, so this will come root of Vm square divided by 4 pi, it is like that, and into 2 pi minus upper limit minus lower limit, right? So upper limit is omega t, change this omega t as 2 pi correct, sin n pi, what is sin 2 pi into 2 omega t? That is sin 2 into 2 pi, that is sin 4 pi, right? So sin n pi is always 0, right? Sin n pi is always 0. So you have, I will write like this, sin n pi is equal to 0, but cos n pi is equal to minus 1 the whole raised to n, right? Minus 1 the whole raised to n. Sin n pi is equal to 0, but cos n pi is equal to minus 1 the whole raised to n. That is sine pi is equal to 0, sine 2 pi is equal to 0, sine 4 pi is equal to 0, etc., etc. But cos n pi is equal to not equal to 0. Cos n pi is equal to, suppose cos pi is equal to minus 1, because n is equal to 1, no, so minus 1 the whole raised to 1, so minus 1. Cos 2 pi, that is equal to cos 360. Cos 360 is nothing but 1, because minus 1 the whole raised to 2, so minus 1 square is nothing but simply positive, so it will be 1. So cos n pi is equal to minus 1 the whole raised to n. That is the equation. So again see, upper limit minus lower limit, no, so sin n pi will become 0 and minus lower limit 0, again sin 0 is 0, so no need to write all, it is simply 2 pi. 2 pi and 4 pi cancel together, it will be 2, so it is will be Vm by or Vrms equal to what? Vm by root. Vm by root. What is the meaning of this? What is the meaning of this? Vrms equal to Vm by root. What is the meaning of this? What is the meaning of this? Rms value is equal to Vm by root 2. What is Vm now? The maximum value of the sine wave is considered to be Vm, right? It is the maximum value of sine wave, that is the Vm by root 2. Root 2 is 1.414, right? 1 by root 2 means 0.707, right? So you can also be write like Vrms equal to 0.707 Vm. This also you can write, right? Vrms equal to 0.707 Vm. Or in other words, see, it means that you need just 0.707 times Vm in terms of DC in order to produce the same heating effect as that of AC can. That means in a circuit, suppose you gave this waveform, this is pure AC, no? This is pure AC, no? Pure AC. So if you given this AC to a circuit and you produced what? Suppose 50 joule heat in 5 seconds. So if you give DC voltage instead of this AC for producing 50 joule in 5 seconds, you have to apply only 0.707 times of Vm. That means you can apply a lower value of DC to produce the same heating effect as that of AC can. That means DC is more effective than what? AC. DC is more effective. That means suppose you have 100 volt AC, no, 100 volt AC in your, suppose you have 100 volt peak value, suppose you have, say like here, okay, suppose you have 100 volt peak value, 100 volt Vm or peak value, 100 volt peak in terms of AC. In DC you need just 70.7 volt. In DC you need just 70.7 volt. DC not need not to be peak, it is simply 70.7 volt in terms of DC. That means if you have a lesser value of what? DC when compared to AC. You don't need that much AC to produce same amount of heat here. You just 0.707 times AC is required to produce the same heating effect. 0.707 times AC is required to produce the same heating effect in DC. That means you need a lesser value. Is it clear? Or in other words, you can say that like also, if you apply 100 volt peak in AC, the working component here is only what? 70.7 volt. That means the working component is nothing but same heat, right? The same heat, right? So producing same heat, suppose you applied this 100 volt, it produces some heat, no? So producing that much heat you need 70.7 means in that AC 70.7 volt is the only working component that is responsible heat. The remaining is lost in some manner. That is very deep concept actually. You just remember this only. DC value is nothing but it is simply 0.70 that of the AC, that is the RMS value. So RMS value is nothing but it is the effective value or DC value required to produce the same heating effect as that of the AC can. And you find out this, what you found Vrms equal to Vm by root 2, which means RMS value of AC is nothing but 0.707 times, which means we just required 0.707 Vm to produce the same heating effect. That's all. That's all. And you learned an equation for finding the RMS value, which is nothing but Vrms equal to root of 1 by 2 pi integral 0 to by V of t the whole square dt for omega t and for time axis. Is it clear to you? Is it clear to you? Its concept is very easy and very you should clearly know the concept. No, you should clearly know the concept. Okay. Is there any doubt for anybody? Please mention in the comment section. Okay, please mention in the comment section. Okay. So you have what the RMS value of AC as Vm by root 2, right? So if you have a voltage like okay, see, you have a voltage like A sin omega t. What will be the RMS value, right? What will be the RMS value? What will be the RMS value? Its RMS value will be what? RMS value will be what? A by root 2, right? A by root 2. And suppose you have A cos of omega t, right? Cos of omega t. What will be the RMS value? It is also simply A by root 2. You can calculate. You can directly apply in your equation and you will find out. You will find out. Okay. It is also A by root 2. And if you have a waveform like A sin of omega t plus phi, its RMS value also what? So this you can remember. This is a trick actually. No, you don't need to calculate. No, A sin omega t plus phi. Suppose you found some equation like, for example, if you find sin omega t minus 90, what is the RMS value? It is simply what? Phi by root 2. Phi by root 2. No need to consider this inside of omega t. What is that inside omega t? No need to consider that. You simply, it is Vm, right? It is the form of V equal to Vm sin omega t. So Vm is nothing but A. So Vm by root 2 is the RMS value, no? So A by root 2 is the RMS value, and here also A by root is the RMS value. Simple. Okay. So that is the concept. That is the concept. Okay. Let's move to a problem. So that our concept will be more and more clear, right? More and more clear. Okay, you write a problem. Okay, yes. Find RMS value. Find RMS value. This is a waveform. Okay, in examination, you may expect a question like this, no? You may given some waveform and you have to find the RMS value as well as the average value. So you just need to find, you just need to remember an equation, right? Remember an equation. That is nothing but for RMS value, what is that? Vrms equal to, what is that? Root of 1 by 2 pi integral 0 to 2 pi V of t square dt sorry, dB omega t for omega t axis, right? For omega t axis, that means the time axis will be in omega t, and which is equal to root of 1 by t integral 0 to t v of t square dt in terms of t axis, right? T axis. So these two equations you have to always remember in your mind. So now you have to use this equation, right? This equation, because it is in t axis, right? It is in t axis. So what will be the value? What will be the value? Let's observe this figure, which is nothing but Vrm is equal to root of 1 by time period. 1 by time period, no? So time period t, there is no change in that. 1 by t integral 0 to what t, there is no change in that also. 0 to t v of t. V of t is nothing but all the time it is what? Vm, no? So simply you can write v of t. Oh, okay, v of t square dt, right? V of t square dt. I will do in the next step. Okay, so it is nothing but, listen carefully, which is equal to 1 by t, 1 by t, right? There is no change in this. This t is for total time period, and this limit is for actual total time period. But how you can solve it? See, how can we solve this? This t is total time period, so 1 by t, there is no change in that. Integral. See the peculiarity of a waveform. See the peculiarity of the waveform. Only for t by 2 time it is exist and having a value of Vm. But from t by 2 to t, its value is actually 0. That means there is nothing. There is nothing there. So that means only from 0 to t by 2 it is exist. 0 to t by 2 it exists. So the integration is from 0 to t by 2 only. 0 to t by 2. And what is the value of from 0 to t by 2? It's simply Vm. So Vm square dt. And from 0 t by 2 to what t? You can write this also, right? No? From t by 2 to t, its value is nothing, that is 0. So this is the total integration. So, total integration. 1 by t is common. Integral 0 to t by 2 Vm square dt plus t by 2 to t 0 dt. So it is nothing but, listen carefully, it is nothing but 1 by t. Vm square is a constant, right? It can be taken outside, and integral dt, it is nothing but t, and it is from integral dt is small t, right? Integral dt is small t, and integration limit from 0 to t by 2. 0 to t by 2. It's a simple integration actually, which is nothing but, listen to me, Vm square divided by t into t by 2, right? Upper limit minus lower t by 2. T and t get cancelled, or simply, which is also, what is that? Vm by root 2. Vm by root 2. Is it clear? Is it clear? Is it clear? So this is how we can find the RMS value. The RMS value. Okay. Is there any doubt? Is any doubt? Is it clear to you? Okay. So let's move to other session, other question. See, by only practice, okay, then only you will be master in your subject. Only by practice, no? Only by practice. So that you can do this problem in many ways, no? You will learn some techniques. So you yourself will what? Invent something. Okay. See. So let's move to next question. Say again. Find RMS value of current. Find RMS value of current. That is our question. That is our question. How can we solve this? How can we solve this? How can we solve this? Okay. So you have, it is of course, what is that? What axis is? T axis, right? So our equation will become Vrms equal to root of 1 by 2 pi naught. It is simply 1 by t, right? So it is a t axis now. So it is simply 1 by t integral 0 to t v of t square. But here it is current, right? So it will be I of t. It will be I of t. So this is the equation for RMS value. See, I already said that for voltage also there is RMS value, for current also there is RMS value, right? So you have to find the value of what? I of t now. I of t now. In the last question, it was very easy to find V of t because it is constant for very long time and it is not there for another duration. So it was very easy for finding the value of V of t there. But here it is something, no, yes, the waveform is slightly different, right? The waveform is slightly different. So how can we find I of t now? How can we find I of t now? That is, I of t is nothing but the instantaneous value of the waveform. The instantaneous value of this waveform. See, and what is the time period now t? What is t now? T is equal to, time period is nothing but, I already said that, time period is nothing but where the wave repeats. That up to that time is called the time period. From where the voltage, waveform starts repeating, up to that time is called the time period. Okay, so here it starts from here, slowly is rise and it's again goes down, again it is repeating, no? So 0 to 2, that 2 is the time period of the waveform, because after 2 it is again repeating. After 4 it is again repeats. So in between this, see, 2, again in between this also 2, in between this also 2, so t is 2 seconds. E is the time period, right? E is the time period. So you got the value of t now, so no confusion there. So but what is I of t now? See, I of t, right? I of t, how can I write I of t? See, this is a straight line which is passing through the origin. This is passing through the origin. Is it clear? Is it clear? And see, for a straight line which is passing through the origin, we have an equation like, see, it is nothing but, no, y is equal to, you have an equation like, see, y is equal to mx plus c, right? Mx plus c, mx plus p. This is a general equation actually. Suppose the waveform is like this, no? The waveform is like this. C is nothing but the y-intercept, and this is the equation for what? This is the equation for y is equal to mx plus c, and you have y is equal to simply mx. This is the waveform. This is x and this is y. This is y. So if you have a waveform like this, it is nothing but what? Slope form of equation, where m is the slope of the curve or line. M is the slope of the curve or line, and that m is nothing but y by x, or which is nothing but tan theta. You already learned this, no? So that's why, no, I speed up now. I mean little what? No need to focus this basic, right? So m is equal to y by x. Y by x is nothing but the y-intercept, the y value divided by the x value. The y value divided by x value, that how much it is in y, how much it is in x, that is y by x is nothing but tan theta, or it is nothing but the slope. This is nothing but the slope. Is it clear? So applying the same here, you will have what is that? Instead of this y, you have I of t here, no? So I of t equal to m into, instead of x, what is here? T, right? Instead of x axis it is t now, so it is t. What is m now? Which is nothing but, what is m now? M is nothing but y value divided by x value. So y up to 10 is there, no? So 10 divided by x is nothing but 2. Up to 2 is there, no? So 2. t, that is I of t, which is nothing but I of t is equal to phi t. I of t is equal to phi t. So this is how you have to derive the line, I mean derive the equation for line. This is how you have to derive the equation for line. Okay, so this is the equation, right? So this is nothing but theta, and tan theta will be y by x. We can do that also. Y terms means 10 divided by x is nothing but 2. So y by x, it is nothing but phi t. So now you have what? Got the equation for I of t is equal to phi t. So substitute here directly. That means Vrms, it is actually IRMS. Okay, this is actually IRMS. Okay, actually IRMS. So IRMS will be equal to what? IRMS will be equal to root of 1 by t, that is nothing but 1 by 2, right? 1 by t is nothing but 1 by 2, right? 1 by 2 integral 0 to t. 0 to t means 0 to 2. 0 to 2. I of t is nothing but phi t the whole square dt. Phi t the whole square dt. Is it correct? Is it correct? Yes. So which is equal to nothing but root of 1 by 2 phi t square means what is that? Okay, 0 to 2 25 t square, right? dt. 25 t square dt. Is it correct? So which is nothing but root of 25, you can take it outside, that is 25 by 2 integral 0 to 2 into t square dt. Is it correct? Is it correct? So up to this, I think you clear now. It is clear now up to this. Okay, it will become, what is that? 25 by 2. What is t square integration t square dt? It is nothing but t cube by 3, upper limit is from 0 and lower limit is from 2. Is it correct? So which is nothing but root of 25 by 2 into what is t cube? So 2 you can apply 2 cube. So it is nothing but 8 divided by 3, right? 8 by 3. And lower limit is 0, right? So no need to find. So it will become 4. So you will have root of 75 by 3 ampere. IRMS, right? IRMS. Root of 75 by 3, right? No, 25 into 4, right? 25 into 4, it is 100, no? 100. Root of 100 by 3. Root of 100 by 3. Is there any doubt? Is there any doubt? I think the concept is clear to you, right? The concept is clear to you. Is it correct? Okay. Is there any doubt, or I want to repeat it again? No need, right? Because it's simple integration, you just need it. But the thing here is that you have to make an equation. That is the main rule, main work there. No, you have to make an equation for the curve or waveform. That is the only task you need here. No, the what difficulty here is that's only the difficulty. Is it clear? Okay. Let's move to another problem. Let's move to another problem. Okay, write down a question. Okay, that's all for the RMS value. And next concept is nothing but average value. Next concept is the average value. I think you already heard this also, right? Average values. What do you mean by average value at all? What do you mean by average value and all? Okay. So average value, I will explain. Okay. See, take a circuit. First you have to take an AC circuit. So average value is nothing but, I will tell the definition first. Okay, average value is nothing but, suppose average value of voltage you have to find, means the average value of voltage is nothing but, it is the voltage required to transfer same amount of charges or transfer same quantity of charges across a circuit at constant time interval. That means, I will explain. Okay, so this is an AC circuit, right? So for 5 seconds, I am observing this circuit for 5 seconds. And for 5 seconds, due to this V of t, there is a flow of current I of t, and there is of course a drop, right? A drop or what energy dissipation across. Okay. So what will be the charge crossing this circuit for 5 seconds of time? That is, you have to notice. We have Q is nothing but charge Q of t. Let be Q of t is nothing but I of t. Q is equal to I into t, right? I of t into total time period. So for 5 seconds means I of t into 5. So this much charge will be transferred in this circuit for 5 seconds. And for second circuit, what will be the value of this V? That is DC, no? What will be the value of this V in order to transfer, in order to make it cross same number of charges in the circuit for the same time. So like RMS value was same amount of heat to be produced, right, for RMS concept, but for average concept, same number of charge to be crossed in the circuit. So now here Q will be equal to I into T. So what is the value of this V required to transfer same amount of charges as that of AC circuit can? That is called the average value. So by definition, you can say like this: average value is the value required to, okay, I will write the definition: value of voltage or current, value of voltage or current required to transfer same amount of charges in a circuit for same time as that of AC can. For same amount of charge in a same circuit, for same time as that of AC can. Is it clear? That means for AC it is I of t into t. For transferring same charges, right? Suppose you take in this time period, that is in 5 seconds, it may transfer 20 coulomb. In AC circuit. For this DC, for 5 seconds, make it to transfer 20 coulomb. Make it to transfer 20 coulomb. How much voltage to be applied? How much voltage to be applied in DC circuit? That is called the average value. Is it clear? Very much clear now. There is no doubt at all. See, I will say once again. We take an AC circuit first. V of t is the instantaneous value. Across R, there will be E of t, right? So in 5 seconds, suppose in this AC circuit, in 5 seconds there are 20 coulomb charge you transferred. 20 coulomb charge you transferred. Okay, in 5 seconds across this circuit, 20 coulomb charge you current is nothing but no flow of charges, right? So 20 coulomb charges you transferred, right? And in the same situation, when it comes to DC, in the same circuit for same time for same charge, what should be the value of V? What should be the value of V? That V is called the average value. That V is called the average value. Or the effective value, we can write here also the effective value. Effective value of voltage or current required to transfer same amount of charges in the same circuit for same time as that of AC can, which is called the average value. Is it clear? Is it clear? Now we have to check this value is greater than V, I mean AC, or less than AC, like RMS value. Okay, in RMS value, what we did for the RMS value, we find the RMS value of an AC alternating current. Okay, a sinusoidal voltage or current, we found out that it is nothing but V is equal to Vm sin omega t. For that, the RMS value will be Vrms equal to Vm by root 2. We found out that by integration we found out that, and we have to check in average value also, it is higher than the AC or it is lesser than AC. You have to find that. Okay, so see, there is an equation for average value V average or current I average, which is nothing but 1 by 2 pi integral 0 to 2 pi 1 by 2 pi integral C of 2 pi V of t d omega t, V of t d omega t for omega t axis, and V average is equal to 1 by 2 pi for omega t, and it is simply 1 by t integral 0 to t into V of t dt for t axis. Is it clear? Is it clear? So let's consider an AC waveform. Let V of t is equal to Vm sin omega t. Vm sin omega t. What is the nature of waveform? You already know this, right? So pi, 2 pi, this is Vm and this is V of t, right? This is V of t and this is omega t. So this is the waveform. So you have to find the average value of this waveform. Okay, V is equal to Vm sin omega t. So what is the average value by definition of the equation? V average is nothing but 1 by t integral 0 to t. What is that? For omega t axis now, it is an omega t axis now. Instead of t, you can write for 2 pi. This also what? 2 pi. 2 pi. What is that? What is that? V of t dt, d omega t. Or in other words, which is nothing but 1 by 2 pi integral 0 to 2 pi integral 0 to V of t is nothing but what? Vm sin omega t d omega t, or which is nothing but 1 by 2 pi Vm you can take out outside. What is sin omega t? Integral sin omega t, it is nothing but minus cos of omega t, integration from 0 to 2 pi, right? 0 to 2 pi. It will be, what is that? Minus Vm by 2 pi. What is cos 2 pi? Cos 2 pi is nothing but 1. And what is cos 0? It is also 1. So 1 minus 1 is equal to 0. A fantastic result, right? A fantastic result, right? V average equal to 0. A fantastic result, right? We did this much calculation and finally you got 0. What is that meaning? Okay, let's see. So you found out the average value of a complete AC waveform is nothing but 0. Nothing but 0. What it means actually? What it mean actually? That means for transferring some charges across this AC, across this waveform, you have to apply 0 voltage. Is it that really mean? Is it that really means? What is the physical significance or physical meaning of this? Physical meaning of this. That means for this AC waveform C, this waveform is positive half cycle and this is negative, right? This is exactly the replica of this waveform, right? Exactly the replica of this. That means if you have V1 here, if you have V2 here, if you have V3 here, the same minus V1 minus V2 minus V3 will exist here also. That means for a complete waveform, if the waveform is symmetrical in nature, the average value will be equal to 0. Average value means you are averaging the instantaneous value. You are sum up or averaging the instantaneous value. You are averaging the instantaneous value means here it is plus V1 plus V2 plus V3. Same time it is for next half cycle is minus V1 minus V2 minus V3 minus V1 minus V2 and minus V3, which means there is a replica of waveform, half waveform. That means it is a symmetrical waveform. For you can say that for a symmetrical waveform, average value will be 0. It is a thumb rule. It's a thumb rule. So if you found any waveform, if you have to find or someone asks you to find the average value of waveform and you are given a waveform, simply observe the waveform. If it is symmetric in nature, that means symmetric means what is meant by symmetric? The same will repeat again for next halves. That's all. Or the mirror image of this will be then below one. That is what symmetric means. That same will happen below also. That is a symmetric waveform. So for symmetric waveform, the average value will be 0. No need to calculate all this. If you find symmetric waveform means the average value will be 0. Average value will be 0. Is it clear? Is it clear? Or what will be the physical meaning of this? What will be the physical meaning of this? Let's check. It is an additional knowledge, okay? Not in our syllabus and all. Suppose you send a current I of t here. It is AC in nature across R. For 5 seconds, you have to pass 50 coulomb, right? 50 coulomb. How can we pass 50 coulomb here? How can we pass 50 coulomb here? See, AC means it having what? It having what? For positive half cycle, you have to transfer what? 50 coulomb, right? 50 coulomb. So for positive half cycle, you have some positive values of voltages in order to pass this 50 coulomb. That means not exactly the 50. No, this half cycle you may have 25 coulomb. You have to transfer. You have to transfer 25 coulomb, right? For remaining this half cycle, you have to transfer another 25 coulomb. Then only the whole total will be what? 50 coulomb, right? The total will be 50 coulomb. So for positive half cycle, you have to transfer 25 coulomb. For negative half cycle, you have to transfer 25 coulomb. Then only it will be total 50 coulomb. So you have to transfer 50 coulomb in 5 seconds means you have to certainly apply some voltages, right? Certainly apply some voltage. So for this it will be plus, it will be plus, it will be plus. But for the negative it will be minus, it will be minus, it will be minus. Same will be existing here also. So average of or the effect of this will be what? Effect of this will be what? 0. Effect of this will be what? 0. That is the concept. Is it clear? I think it's very much clear to you. Right? Okay. So average value of whole cycle of an AC will be what? 0. Whole cycle of AC will be what? 0. Or what will be the average value of half cycle? What will be the average value of half cycle? What will be the average value of half cycle? Okay, for half cycle, that means you have just from here to here only. You have this much only. 0 to pi only. You have this much only. Because when we take the full cycle, that will be of course 0. Then what is the average value of a half cycle? Let's see that. Let's see that. Let's see that. Okay. So this is omega t. Let's calculate that. V average is nothing but again 1 by 2 pi. But here it is only pi, right? Here is only pi, right? Because we are only taking for the half cycle. So only that half cycle exists here. Pi integration from 0 to pi Vm square d omega t. Right? So V of t square d omega t, or which is nothing but 1 by 2 pi 1 by pi integral 0 to pi. What is V of t now? V of t is nothing but Vm sin omega t d omega t. There is no change in that. Or which is nothing. Oh, sorry. This is not square, actually simply V of t dt. Okay. So which means V average is equal to 1 by pi integral 0 to pi. This Vm can be taken outside. Vm, what is that? Sin of omega t d omega t. Is it clear? So it will be nothing but Vm by pi, right? Vm by pi, it is, listen to me, what is integral sin omega t? It is minus cos of omega t, and integration from 0 to pi, or which is nothing but minus Vm by pi into cos pi, it is minus 1, minus cos 0, it is again minus 1. So it will become 2 Vm by pi. So V average will be equal to 2 Vm by pi for what? For half cycle. This is the equation. So for half cycle of AC waveform, the average value will be equal to 2 Vm by pi. So now you can use this concept for what, like RMS also. Suppose Vm equal to what? Say Vm equal to what? 2 volt. Simply Vm. Okay, you compare with what? AC, no? So V average equal to 2 Vm by pi means whether it is higher or less than AC, that you have to check. V average is nothing but DC or average, right? So whether it is higher or lesser than AC, you have to consider. 2 Vm by pi or 2 by pi means 2 by 3.14. It is also less. It is also less than 1, right? So it is a less than 1 into Vm. That means average value concept also, you need lesser voltage than AC in order to produce the same charge transfer in a circuit. You not need that much amount of AC to transfer the charges from, across any point in a circuit. You just need lesser DC as compared to AC for transferring the same charges. That is the concept. Is it clear? The average value concept is clear to you? Okay, let's check the time now. Okay, time is there. So that is the concept. Is it clear to you, right? Is it clear to you? Okay, so let's move to another problem. So that it will be very clear, very clear. So see, you have to find average value. Find average value. Find average value. How can we find the average value? So again apply, it is a t axis now. So we can apply the equation now. V average is nothing but 1 by t integral 0 to t v of t dt, right? V of t dt. So it is nothing but 1 by t. T is nothing but time by t integral 0 to t integral 0 of t. V of t is nothing but, okay, I will write again v of t dt once again. I will explain. So it is nothing but 1 by t. The integration I can split it to, see, 0 to t by 2 it is Vm and t by 2 to t it is nothing. So I can split the integration as 0 to t by 2 Vm dt plus t by 2 to t, there is nothing, no, there is 0 dt. So I split the again, I can split the integration, right? I can split the integration. That means from 0 to t by 2 it is Vm and from t by 2 to t it is nothing, it is 0. So 1 by t is common, right? 1 by total time period is common, it can be taken outside. Integral 0 to t by 2 Vm dt plus t by 2 to t 0 dt. That means which is equal to 1 by t, Vm can be taken outside, Vm by t, right? Vm by t, right? So it can be taken outside. So what is integral dt? It is simply what? Simply what? T. Integral dt is simply t and integration from 0 to t by 2. And integral 0 t is no need to find, which is equal to Vm by t. Instead of t you can apply t by 2. So t by 2. T and t get cancelled, it's simply Vm by 2. So V average equal to simply Vm by 2. This is the concept. So how easy the problem is, right? How easy the problem is if you know the equation. There is another equation for finding the average voltage, I mean average value also. It is nothing but area average value is nothing but area under the curve divided by time period. This equation you can use, okay, this equation also you can use. I prefer always the standard equations. Okay, so this also you can use, no? So average value of voltage or current is nothing but area under the curve divided by time period. Let's check here it is correct or wrong. Okay, now here the area under this curve is nothing but, it is a, see, it is a rectangle, right? It is a rectangle. So area will be nothing but length into breadth, height, length into this breadth, that will be the area, right? So L into B I can write like, and total time period, total time. So it is nothing but beta, see, length is nothing but t by 2, right? T by 2 into time is nothing but, I mean breadth is nothing but Vm whole divided by, what is the time period now? This is the time period, right? This is the time period, because after this the waveform is repeating. So this is the time, total time, right? So this is the total time. So t is nothing but t itself. So t and t get cancelled. So V average will be equal to again. So both are same, right? Both Both equation you can use. No issues there. So it's up to you for what equation you prefer. Anyway you can use both equations, no issue. Is it clear? So that is the concept of average and RMS value. Okay, so that's up to today. So let's meet again tomorrow. So until then, and please share the video, okay, and please you have to prepare your own notes. I will explain what is the importance of your own notes. See, there may be many printed notes available in market as well as on online, Telegram and all. You will get definitely some printed notes or some written notes by some others, right? That is not at all worthy for you. Suppose you prepare a note by yourself. This is my note. This is I prepared by myself. So I have 4 or 5 notes like this in order to complete all the syllabus. In order to complete all the syllabus, I have 4 or 5 notes like this. That means it's my style of language, it's my way of writing. That means my ideas will be there in my notebook. So this is the only thing which most helpful to you in the examination. That means if you read some printed note and all, more effective will be your note. If you have your own note, then compared to printed note, the more effective will be your note. So please make a habit that you have to write a lecture note in your own way, in your own language. Okay, no need to focus on whether my English is correct or not, whether my language or grammar is correct or not. Don't think of that. English or what? English is just a language. It is just to communicate the idea to others. You don't need to focus. You are not going to take PhD in English, right? No. Your aim is to crack the exam. Your aim is to grab the knowledge of your electrical engineering. So language is not at all a barrier for us. Okay. So in your own language, you have to write. Maybe my classes are slightly more faster than others. No, faster. Maybe you may feel like, because it's a video in YouTube, right? So you can pause play in your own convenient. That's why I take it in my own speed. So in YouTube there is an option in slow, not 1.5x, 0.5x, 0.25x, like that. You can adjust the speed also, so that you can extend the video for some more time. So that's according to or up to you. Clear? So the thing is, you have to make your own notebook, then only it will be more effective. Okay, so that's for today. So we'll see you on tomorrow. Okay, so goodbye and take care.